This is problem 2 on specimen paper 3. It says consider the differential equation, and it gives us some conditions. You don't have to worry about the conditions as far as solving. It could help you if you were solving for a constant or something like that towards the end of a problem, but you don't need that in the beginning. It says show that this is a homogeneous differential equation, and then you're just going to solve it. Okay, so that's our goal. So in the A part, we just want to show that it is homogeneous. Okay, so the first thing you want to do is you want to solve for dy dx. Okay, so all that means is I have to divide both sides by x. So I'm going to do that first. So you have y plus the square root of x squared minus y squared all over x. Okay, and all you have to do is look at the degree of the numerator and the denominator. Okay, this is degree 1. If you take the square root of something squared, that's degree 1, this is degree 1, this is degree 1. The highest power of each term is to the 1. Okay, so the numerator and the denominator are of degree 1. Equal degree is what you're looking for. Okay, so the differential equation is homogeneous. Okay, so that's all they want in A. In B, they actually want you to solve. Okay, and what you do is you divide the numerator and the denominator by x to the 1. So just put numerator and denom by x to the 1, x to whatever the power was of the degree. Okay, so we have dy dx. If you're doing that in both the numerator and the denominator, you're essentially dividing by 1 on this side, which doesn't change anything. Okay, so divide every single term. So you have y over x, and in the denominator x over x. Now if you're underneath the square root, to divide by x, x is the same as the square root of x squared. Okay, so we're going to have the square root of, and this would just be x squared over x squared minus y squared over x squared. Okay, just dividing each of those terms by the square root of x squared, which is just x. Okay, and so we'll simplify that. We'd have dy dx equals y over x plus the square root of, this is x squared over x squared, which is just 1. This, I'm going to go ahead and write as y over x quantity squared. And x over x is just 1. Okay, now this is something you have to remember for homogeneous. You have to remember y equals vx. They give you the integrating factor in the formula sheet, but they do not give you this. So if you're making a list of things you need to remember for the IB exam, I would definitely put your rules for product and sum of roots, because that's not on there on the formula sheet, and I would have your series tests, and I would have that for homogeneous functions you have to remember y equals vx. Okay, so as you work through these review problems, if there's something comes up through any of these review tests and it's some kind of formula you need and it's not on the formula sheet, I would just have a running sheet where I wrote stuff down. It could really just be your series with a couple of formulas written on the back, and that ought to take care of you. Okay, so y equals vx, and then we're going to solve for v, which would be y over x. Okay, and that's what all these guys are going to turn into, and we also need to know what dy dx is. Okay, and so what you're doing is you're taking the derivative all the way through this equation with respect to x. So the derivative of y with respect to x is dy dx. I'm going to use product rule on this. So it would be first times the derivative of the second, and the derivative of x with respect to x, it would be dx dx, which is just 1. That's first times the derivative of the second plus the second times the derivative of the first is dv dx when you're taking it with respect to x. Okay, and so now I'm going to use these substitutions to change this into a problem with all v's and x's. Okay, so instead of dy dx, every time you're just going to substitute in v plus x dv dx. Now if you just want to remember that, you can. Okay, we're making the substitutions into this. It's just easier for me to remember this and then just take the derivative of it. Okay, instead of y over x, you're going to put v plus the square root of, this guy's v, so 1 minus v squared. From there, it's a separation of variables problem. Okay, so you're going to want to get all your v's on one side and all your x's on the other. To be frank, this is where most of you guys miss this problem. Okay, you think you can do all the algebra in your head and you move stuff around incorrectly, And it gives you a problem that you then try to solve, which is sometimes more complicated than the one they want you to solve. Okay, but first off, you can just subtract v. So if you subtract v, this would be gone. Okay, I'm going to do this step by tedious step because, like I said, you guys sometimes try to skip through here, and that's where you miss something on this type. Okay, on this, you're never going to have dx in the denominator when you're separating your terms, separation by variables. You're always going to have your dv and your dx. Neither one will be in the denominator. So I'm going to take a step just to multiply both sides by dx. Okay, and that's because I know that's not going to end up in the denominator. So x dv equals the square root of 1 minus v squared dx. Okay, so now these are kind of set in stone. The v's have to be on this side and the x's have to be on that side. Well, if I want the x's on this side, I'm going to need to divide by x. Okay, so I'm going to do that one step here. Okay, so now I've got dv equals the square root of 1 minus v squared over x dx. Okay, this guy has to move over here with the v's. So we're going to do that by dividing both sides by the square root of 1 minus v squared. Okay, so this is going to cancel. So we have dv over the square root of 1 minus v squared equals 1 over x dx. Okay, now you've got your variables separated. The next thing you're going to do is integrate. Okay, so if I'm going to do that, let me just start a new page, put your O2. Okay, this guy is pretty easy to remember, right? That's ln of the absolute value of x. Okay, and we usually put our plus c on our right-hand side. The other guy, I would probably have to look up. Okay, if you look right here on your formula sheet, and even your 1 over x is up here with the absolute value. Okay, but that looks like this guy, and we just have a 1 for a, so this would just be arc sine of, and we have v for this. This would just be arc sine of v over 1. Okay, you only need your plus c on one side. Okay, so this guy right here would be arc sine of v equals ln of the absolute value of x plus c. Now, to undo arc sine, the inverse operation of arc sine is sine. So you are going to take the sine of both sides. Okay, the c stays within that sine. That's very important. Okay, now the other thing that you have is they did tell you up in the beginning of the problem, x is greater than 0. So if x is greater than 0, I really don't have to have the absolute value around this. I can drop, because x is greater than 0, I can drop the absolute value. Okay, so sine of arc sine of v, those undo each other. So you have v equals the sine of ln of the absolute value of x plus c. Okay, the one thing you have to remember at the end of the problem, oops, I already got through telling you didn't need that. You have to remember to substitute back in for the v. Okay, so v, if you'll remember, was y over x. Okay, so we're going to have y over x equals sine of ln of x plus c. It needs to be solved for y. I believe it tells you that. Find the general solution, giving the answer in the form y equals some function of x. Okay, so this is almost done. Just multiply both sides by x. That would cancel. So you have y equals, I'm going to put the x in the front, x sine of ln of x plus c.